Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss the real number system. Now, there's two categories in the real number system. The first category is rational numbers. So our first category is rational numbers. So let's discuss what rational numbers are. Some decimals, such as 0.5 and 0.3125, terminate. They terminate. So these two decimals terminate. And what does terminate mean? It means they end. So when a decimal terminates, it ends. They have a limited number of digits. Now, other decimals, such as 0.3333 and 0.181818, what do you notice about those two numbers? They are repeating. So they have a repeating pattern of digits that never end. So terminating or repeating decimals are called rational numbers. So terminating or repeating decimals are called rational numbers because they can be expressed as ratios of integers, better known as they can be written as fractions. So if a number can be written as a fraction, it is a rational number. So now let's look at some examples of terminating or repeating decimals. We have 1/2. Well, what is 1/2 as a decimal? It is 0.5. 0.5 ends. Okay, this ends. So therefore, it is a rational number. All right, the next one is 5/16 or 5/16. If we divide the numerator by denominator, we get 0.3125. Again, it ends, it terminates, therefore it's a rational number. Our next one is -1/3. Well, we have 1 divided by 3, and that equals -0.33333333. The 3 keeps going, so we put a repeating bar on top, and therefore, because it repeats, it is a rational number. Lastly, 2/11. And if we do 2 divided by 11, we're going to get 0.18181818181818 keeps going. So 0.18 repeating, and therefore repeats. These are rational numbers. Let's look at some more examples of rational numbers. So now let's discuss some additional examples of what rational numbers include. Rational numbers include integers. Now, an integer is a number with no fractional part that includes positive and negative numbers in addition to 0. So an integer is a number with no fractional part that includes positive and negative numbers in addition to 0. For example, -3 is an integer. -2 is an integer. -1 is an integer. We have some negative numbers. It also includes the number 0 as an integer, and then also our positive numbers, for example, 1, 2, and 3. So we have negative numbers, 0, and positive numbers with no fractional parts are included as an integer. Another example of a rational number are whole numbers. And whole numbers are numbers that include positive numbers without a fraction and 0. So whole numbers are numbers that include positive numbers without a fraction and 0. So examples of whole numbers include 0, 1, 2, and 3, and so on and so forth. So whole numbers are positive numbers without a fraction and 0. Now I'd like to say, in the word whole, you have an O in it, which can be represented as a 0. And that's how we know a whole number includes 0. Next are natural numbers, which is also a rational number. A natural number are positive numbers without a fraction. So natural numbers are positive numbers without a fraction. For example, 1 is a natural number. 2 is a natural number. 3 is a natural number. 4 is a natural number, and so on and so forth. They're all positive numbers without a fraction. Now, the main difference between a natural number and a whole number is a natural number does not include 0. So a natural number does not include 0, where a whole number includes 0. Okay, let's talk about some more examples of rational numbers. Okay, so let's discuss more examples of rational numbers. They also include fractions. For example, 1/2 is a fraction, 3/4 is a fraction, a negative fraction like -2/5, or -7/10. These are all examples of rational numbers. Rational numbers also include percents. So for example, 50% is a rational number. 200% is another example of a rational number. And also negative percents like -4.5% is a rational number. Decimals are also rational numbers, but they're decimals that end or repeat. So only decimals that end or repeat are rational numbers. So for example, 1.6, that's a rational number. It ends. Another example is 4.12 repeating. Since it repeats, it's a rational number. Another example is -8.6501. It ends at 1, therefore it's a rational number. Okay, and lastly are perfect squares. Perfect squares is an example of a rational number. And a perfect square is a product of a rational number multiplied by itself. So a perfect square is the product of a rational number multiplied by itself. So what does that mean? For example, if I have the square root of 4, what times what gives us 4? 2. So the square root of 4 is equal to 2. That is a perfect square. Another example is the square root of 16. The square root of 16 is equal to 4, because 4 times 4 equals 16. Another example is the square root of 81. That is a perfect square. The square root of 81 is equal to 9, because 9 squared, or 9 times 9, equals 81. Okay, so now that we discussed rational numbers, let's discuss our next category of the real number system. The second category of the real number system is called irrational numbers. So let's define irrational numbers. An irrational number is any real number that cannot be expressed as a ratio of integers. Informally, this means that an irrational number cannot be represented as a simple fraction. Irrational numbers are those real numbers that cannot be represented as terminating or repeating decimals. So irrational numbers are real numbers that cannot be represented as terminating or repeating decimals. The most famous irrational number is pi. Pi is a decimal that keeps going and going and going. It never ends. Therefore, it is an irrational number. Think of irrational. If someone's irrational, they keep going and going and going. It never stops. It's the same thing with decimals. They're decimals that keep going and going and going. They don't terminate. They don't repeat. It never stops. Another example of irrational numbers is the square root of 2. This is not a perfect square. So if I put the square root of 2 in my calculator, I'm going to get an ongoing decimal that keeps going and going and going. Another example is a number that has a pattern. So for example, if I have 0.101001 and it keeps going, that is an irrational number. This just has a pattern. It keeps going. It doesn't repeat. It's not terminating. So another example of an irrational number is, say, 3 pi. Again, you have pi here. It's multiplied by pi. Anything with pi would be irrational. Another example is the square root of 61. It's not a perfect square. Take the square root of it. It keeps going and going and going. So some examples of irrational numbers include not perfect squares, anything with pi, and decimals that do not repeat or terminate. So examples of irrational numbers typically include anything with pi, not perfect squares, and decimals that do not repeat or terminate. So now let's look at the real number system chart. So let's look at the real number system, and we're going to start with the center, natural numbers. We discussed natural numbers include positive numbers. So we have, for example, 1 is a natural number, 2 is a natural number, and 45 is a natural number. All examples. Now let's discuss whole numbers. So a whole number is a natural number that includes 0. So the word whole in it, remember, we said has the number 0 in it. So 0 is a whole number, 1 is a whole number, 2 is a whole number. You can say 100 is a whole number, and something like 8,000 is a whole number. These are all examples of a whole number. Our next category is integers. And we said that integers were positive and negative numbers that had no fractions and also include 0. So for example, an integer includes -3 or -7, -42. They are negative numbers. Additionally, integers include 0 and positive numbers like 1, 2, and 75. So they're positive numbers, negative numbers, without fractions, in addition to 0. Lastly, are rational numbers we discussed. And we discussed a lot of rational numbers. So for example, rational numbers include 0, 1 and 2, which are positive numbers. They also include negative numbers like -3 and -7. And they also include fractions like 1/2 or -3/4. Percents like 50%. Decimals that terminate or repeat. So terminating decimal is 1.7. And a repeating decimal is 2.33333 repeating. And then lastly, it includes perfect squares, like the square root of 4. So after discussing the rational category, now let's talk about the irrational category. And irrational numbers include pi, anything with pi. It includes square roots that are not perfect squares, like the square root of 17. And it includes numbers that keep going and going and going, like 2.14, 114, 1114, and it keeps going. So we have two key concepts you have to understand here. Okay, if we have a natural number, it is also going to be a whole number, an integer, and a rational. So why is that? Let's look at the chart above. We had a natural number, which is 1. If you look, we also had 1 in a whole number, and an integer, and a rational. So whenever you have a natural number, it's going to be included in anything above in the chart. So a natural number is also going to be a whole number, an integer, and a rational. So wherever you start in the chart, it's going to include everything above it. So therefore, a whole number is going to be an integer and a rational. So if you look at a whole number, say we have 0, for example, 0 is included into an integer and a rational. So a whole number is an integer and a rational. And an integer would also be included with a rational. So an integer is also a rational. Now, if you look at the irrational category, irrational always stands alone. Nothing else is included in an irrational number. It's just irrational. So now let's do some examples together. It states, name all the sets of numbers to which each real number belongs. So let's look at number 1. It says -8. You want to first identify where -8 starts. So -8 would start in the integer category because it's a negative number. And if it's an integer, it's also going to be a rational. So your answer is integer and rational. So -8 is integer and rational. Number 2, the square root of 46. Well, the square root of 46 is not a perfect square, and therefore it's a long, ugly decimal, and that would be irrational. So number 2 is irrational. Number 3, 22. Well, 22 is a positive number. Therefore, it would start in a natural number. So if it's natural, it's also going to be a whole number, an integer, and a rational. So wherever it starts, everything else is included. So it's a natural, whole, integer, and rational. Number 4, 3/5. Well, where does 3/5 start? It starts in this category, so it would be a rational number. Just rational. So 3/5 is rational. Number 5, -2.71 repeating. It's a repeating decimal, therefore repeating decimal is rational. So number 5 is rational. And then number 6 is 0. So where does 0 start? 0 starts with whole. So it'd be whole and everything above it. So it's a whole number, an integer, and rational. So 0 is a whole number, integer, and rational. 0 is the only number that includes all 3 of those categories. So now what I would like you to do is the You Try section. Please complete problems 1, 2, 3, 4, 5, and 6, and we will discuss these questions in class. Thank you.